Hi, it's Pekka from Gokbullet and welcome to my office. So this is actually my home. There is computer, cup of tea, that is all I need. And then I have over here, I have first tip what I'm designing at the moment. It's a guide bar and a chain for the chainsaw. And then next tip is that I have this video from the 7 years ago I made testing mini harvester head first prototype. So that's what I've been doing 7 years ago, and now I'm doing it again. 7 years ago it's a long time, but tada! Over here we have next version for those mini harvester heads. So I have been designing this now. I had one guy who was helping me, and then I did again redesign that. So it's like one guy did want to do trainee, so I gave him like opportunity to design, and then he did actually send me package of the drawings, and then I did again redesign from those drawings again this. So it's not just me this time, there is also one guy. But anyway, it's like main thing is actually it's again me. And we're here, let's take this to the normal position so it's easy to see. So you might notice that it's a roller harvester head. It's that angle over here. I think this is the best one to show. So there are rollers. Other alternative would be the stroke, which is that it always goes in and out. So the tree is moving like it pulls the tree all the time. This is like with rollers, so it drives the tree. The size, it's about 200 kilograms, so it's a small one. The normal small ones are from 300 to 400 kilos and up. So this is about 200 kilos. 100 kilograms would be perfect, but all the component weights like drive motors and valves and cylinders and everything like that, it already gives so much weight that it will go close to 200 kilograms. And the size, what is my plan to cut down with this, is about, I think average is 10 centimeters trees. So the early first thinning, and then like maybe 15 centimeters. So little bigger trees, but not like any huge trees, because there is just too much weight. Right? You can go big huge machine over there to cut down big trees. No idea to make small harvester head for that. But anyway, so over here there is this kind of small tree over here. And what happens next? You take this, like you move this next to the tree, and then you take these drive motors also next to the tree, and also these debarking knives. And then over here we have a chainsaw. It cuts down with drive motor, and I will use this kind of normal guide bar. So this is for the chainsaw. It's not for the harvester head, because everything, more or less all the harvester head special stuff is made for those huge machines, not for this small stuff. So I have to use like the regular small stuff. And then I have to design more or less everything by myself, because there is nothing ready in the market. The chain speed will be about 80 meters per second, and that is the same speed than in the professional chainsaws. So same chain and professional chainsaw, so it's about that speed. And in the small trees, if you know that you have like bigger Husqvarna or steel chainsaw, it don't take too long to cut down. And of course there's so much power that it will just go through. Yeah. And then what happens next? These rollers, of course we can take these debarking knives and this little out from the tree, and then the rollers start to drive wood. That is, I think, my target is that 3 meters long pulp wood is about 2 seconds. So it cannot be like half seconds, because it would be so dangerous and everything would be changed. So it's like, target is 2 seconds per 3 meters. Let's see how that will happen. Of course I don't know yet, because I have to first manufacture first, take that to our forest. I already know the spot where I will take this, and then like debark, cut down trees and debark and that kind of stuff. A deep branch, so not bark should stay over there, just like those branches away with knives. Sorry. And then again, we will cut down after 3 meters. There is measurement wheel over here, so we know that it's 3 meters. And like over here, you can see how it, like these knives are working. So those comes over here, and like those just can follow all the time 3. That is nice, I think. Yeah. And the structure over here, this is what valve cover. Now you might think that it will be green. For some reason, I use in Fusion 360, and there is no orange in that. So it has to be green that way. Most likely it will be orange, that valve cover. And inside over there is valve. That I will actually design that valve because when I design the valve, I can make it like I want it to be. So less hoses, less like separate valves and that kind of stuff. So it's so much more simple to make it that way. And I will use setup valves. That is, when I use the setup valve, it means that you can go to your local hydraulic store. Like you can go to your local store to get these. So you don't have to contact me for the setup valve if you have some problems with those. Most likely you will not have, but if you have, it's totally standard. Like dry motors and all the components are so standard that you can get those worldwide now and in the future. So that is one how I like to design. Other stuff how I design is actually, I first think about the price. I don't want to make the most expensive machine in the market. I want to make the machine that you should purchase because it's good price. So it's like good, and yeah, so I prefer to make more units with less profit than few units with huge profit. That is how I like to do it business, because then I can make those more, and it's also like, I think it's like normal business is to do it that way, not like try to make like few times whatever wins. Yep. Yeah, but one thing is because I have the price which is reasonable. Of course, I don't know what every different people think what is reasonable price, but then it gives me pressure to make good cost, because I have to make healthy business over here in my end also. So then I have cost, and to have good cost and good quality, I just have to design these for the manufacturing. So everything I'm doing over here, I'm just all the time thinking like how I will manufacture this, how it will be simple to manufacture. So like one sample over here is, so this component which is hanging so this one, so it's like that one where it's hanging, this, it looks like this. So I have over here slide bearing and it goes like this, and this is other cylinder end. And just this component then looks like this one, and then and for me it looks like this when I design. Then I have over here the bending lines. Next step what I have to do is actually I have to make this like cutting file, how they will cut this with laser, and also file to show how to bend it. And again, like my design over here, you can see this kind of little hole. There is no purpose for the machine, but it's just for the manufacturing. So over here, we will weld this next to that, and there is also this hole and this hole. And then when I'm welding this, or somebody is welding, so this hole, and then over here bolt and the nut. And then it's so simple to weld, because this tape measure, this kills the efficiency in production. Obviously, when you have to measure something, it just takes so long time, and the quality is bad, because if you make measurement mistake, then you have mistake in your machine. But over here, when we have this kind of hose and the bolts, it's super cheap. We always have the bolts in our workshop. Nothing special, no special expensive fixtures. And then place it over here, weld, have good machine. And other thing what I'm doing all the time is that I want to use the same component in several spots. So like these debarking knives, these ones. These are actually these ones. I have two the same debarking knives. So when I manufacture those, I just have to manufacture one. I don't have to manufacture two different and have do different drawings and do different everything. And like this component, this which is holding over here, those are also the same bushings. So again, I guess components, it's because it saves a lot of, there is two benefits with that. One is when I manufacture something, if I have 8 or if I have 20 components, I most likely I will have 8 components in my shelf because I have bigger amount of those all the time. And then if I have 20, most likely I will be missing one small component, and then I'm in the problems. And the cost, if you make less components with higher volume, so then with the smaller amount of the harvester heads, I get bigger batches in the manufacturing, and then that means that I get more reasonable price because for my subcontractor, it's also more, they spend less hours with those per unit, and then you get with better price your harvester head. Because about 80% from the end cost is actually, it's made over here in the design. If I make over here super complicated product, then if I try to make like production efficient, it don't help anymore. But if I make over here everything so simple and efficient over here in this end, in the drawing table, then this will be so simple to manufacture, and then everybody are more happy. Yeah. So this is something what I've been doing over here. It's just now at the computer. It will take a long time for me to make those drawings, and then like I haven't yet designed the valve to the end, and then of course like manufacturing components, that will take a long time. But my dream is, I don't know will it happen, but because there is like so many things that can happen, but like next summer, for example, I'm dreaming to go to one birch forest with this, but let's see if it will happen, because I need to also have Megamax, which I'm at the moment also manufacturing. Yeah. If you did like this, please thumb up and other stuff, and see you. Bye.